Hi everyone, this is Core 4 June 2008 question on integration. This is a WJEC question, but this type of question does appear on most of the exam papers. So I've written out some of the question already. What I have is, use x equals 3 sine theta to show that the integral of 9 minus x squared dx, all square rooted, with the limits 3 and 1.5, equals limits of b and a integral of k cos squared theta d theta. So I've already written out the x equals 3 sine theta. Rearrange that and you can get that theta equals sine minus 1 x over 3. This is an example of substitution method of integration. So I do need to know the values of theta for both of the limits. So here are my limits for x. The top one is 3, that's the maximum, and the minimum is 1.5. Now if I put that into my calculator, so sine minus 1, 3 divided by 3, which is sine minus 1, 1, which gives me pi over 2. And this would be sine minus 1, 1.5 divided by 3, which is sine minus 1 half, which gives me pi over 6. So my new integral is going to look like that. So now what I'm going to do is find out the value of d theta. So now what I'm going to do is find out the value of dx. So I know that when I differentiate x, I get dx over d theta, which is differentiating x with respect to theta, equals 3 cos theta. Now rearranging this, I get that dx equals 3 cos theta d theta. So now starting with this integral, 3, 1.5, 9 minus x squared dx, I can substitute in the values that I know. So the integral becomes pi over 2 over pi over 6 square root of 9 minus, now I know that x equals 3 sine theta, so 3 sine theta squared, and then dx we know is 3 cos theta d theta, 3 cos theta d theta. Now it's just a case of rearranging this and trying to make it into the form bak cos squared theta d theta. So the first thing I'm going to do is square this value. So that becomes 9 sine squared theta, all square rooted, 3 cos theta d theta. Now I can take the 9 out of this. So that becomes 9, 1 minus sine squared theta, all square rooted, and all within the integral. So now if I take this 9 out of the equation, out of the square root, so you square rooted it into 3, it becomes 3, 1 minus sine squared theta, like that. So now all I'm going to do is times this 3 by this 3. That's going to give me 9, 1 minus sine squared theta, cos theta is still over there, pi over 2 and pi over 6. So now I know that 1 minus sine squared theta, using the equation cos squared theta plus sine squared theta equals 1, rearranging that, I know that cos squared theta equals 1 minus sine squared theta. So that means that this is the same as cos squared theta square rooted 9 pi over 2 pi over 6 cos theta. So now I can work on this. So what I'm going to do next is I'm going to square root this element. So square root of cos squared theta just becomes cos theta, but then when I times it by this cos theta, it gives me cos squared theta again. That gives me 9 cos squared theta d theta, same integrals, pi over 2, pi over 6. So now I can compare this to the original question, which asked me for b, a, k, cos squared theta, d theta. So now looking at this, I can tell that b equals pi over 2, a equals pi over 6, k equals 9. So that's the answer to the question. Now, the question goes on to ask for it asks you to hence evaluate the integral. So hence evaluate 3, 1.5, 9 minus x squared all square rooted dx. So we've already worked out that this is equal to pi over 2 pi over 6 9 cos squared theta d theta. So rather than integrating this, we're going to integrate this with respect to the integrals, the limits of pi over 2 and pi over 6. So nice and easy, what we're going to do is take the 9 out. So we have cos squared theta d theta. Now this is integrating an even power of cos. Now using the double angle formula, cos 2 theta equals 2 cos squared theta minus 1. I can rearrange that now to make 2 cos squared theta equals cos 2 theta plus 1. So cos squared theta equals half cos 2 theta plus 1. So this is going to become 9 half cos 2 theta plus 1 d theta. Now remember, we still have the integral here, pi over 2 pi over 6 pi over 2 pi over 6. Now I can integrate this entire thing. But first what I'm going to do is take out the half and take out the 9. So it becomes 9 over 2 pi over 2 pi over 6 cos 2 theta plus 1. So now you've simplified it into a form which you can easily integrate. That should be a 2. Right. So integrating cos 2 theta gives you half sine 2 theta plus theta. You still have your 9 over 2 on the outside, with the limits of pi over 2 and pi over 6. So now WJAC do give you the mark for this. If you did want to go further, 9 over 2 half sine 2 pi over 2 plus pi over 2 minus half sine 2 theta over pi over 6 plus pi over 6. That would give you the final answer, which I shall work out now. which I worked out as minus 117 over 20.